Okay, took a few minutes, but you got it. The first picture I saw on your paper broke this down to 2 dimensions, and this is not a bad thing to do. We have an axis here. It's not the X or the Y axis because we got the Z axis here. And you wanted to put the point X star, Y star right here. That's good. Okay? You can do that. I would have drawn it in 3 dimensions, but this is equally good. All you have to do is ask yourself now, let's see, we can form a triangle here, and we know this side is R, so all we got to do is find this side, and now we know how high we got to go to get, how high we got to go before we hit the edge of the sphere, okay? The boundary of the sphere. Okay, so we take this triangle here, draw it a little bigger, and say, okay, let's see, this is R. Now we need one of these legs. Clearly we don't know this one, that's what we're trying to find. So this is what we're trying to find, and we have to know this leg. Okay, now the whole thing is you had this picture. You didn't quite ask yourself the right question. That's good. I mean, getting the picture, before you've seen it and all that stuff, that's pretty good. Okay? Now, the question you have to ask is, well, what's the length of this leg? Well, how do you break that question down? This leg goes from the origin to the point X star, Y star. Right? So this leg has to be what you get from the Pythagorean theorem, X star squared plus Y star squared, square root of that, right? And then this one is really easy. This will be the square root of R squared minus X squared plus Y squared, because it's going to be the hypotenuse minus the square of this, right? And that's an X star and a Y star. Okay, there it is. Now that's the top of the sphere. Obviously there's a symmetry, and down to the bottom of the sphere you go the same distance in the opposite direction. Okay? Okay, so negative square root of R squared minus X squared, X star squared. Well, I used the X star here to emphasize the whole idea of sample point and everything, but when you're just setting up the inequalities, you don't use stars necessarily. You can. And when you're partitioning, that's when you start using stars, usually. And I will occasionally violate that. I think I did last time, because there was a point I was trying to make. Anyhow, that's your third condition. If X is allowed to go from negative R to R, and then Y from negative square root R, okay? Then you have a description of the circle in the plane. Then you just take a typical point on that circle and ask how high do you go, how low do you go? And it comes out real easily. Okay? So now, you partition everything, okay? So we could start, we could start by saying, X naught less than X1. And I'm going to write out kind of the whole thing, just in its gory detail, okay? Well, obviously I'm not going to write all these because we don't know how many there are going to be, but so we have a partition consisting of n intervals. This is your typical subinterval. This could stand for any subinterval. Okay? And then we'll say that xi star is in the interval xi minus 1 to xi. That kind of, this is a partition, but once we have the partition, we do want a sample point in each interval. Then what? We have negative square root of r squared minus x squared equal y naught less than y1 less than up to n. Okay. Not be as careless as I was last time. yi0, yi1, yij minus 1, yij, not xij. Keep on the right axis. It's supposed to be less than, right? Y I M Okay. So for a typical I, we have these limits on J. And I explain all the details of that. And then Y I M star is in the interval Y I, it's not Y I M, Y I J, J minus 1, Y I J. Make sense? Okay. Then we have Z, right? Now you have a Z for every XY. Okay, so your Z is going to go from negative square root of R squared minus XI squared minus YI J squared, okay? And that's going to be Zij0, right? Because the partition is unique to the Xi and the Yj, okay? I'll abbreviate this just a little bit, but and now we'll have a Zij k minus 1. Now, sometimes I'm using commas and sometimes I'm not. I'll use a comma when I've got to do arithmetic in one of my subscripts. Otherwise, I'm not even going to bother with the comma, okay? You probably should to be consistent. But I think my meaning is as clear as I can make it, okay? And that is going to be Z Ij I left a subscript off here. The M here depends on I, depends on what your X is, right? So that should be I sub M sub I. Not sub M, but Y M sub I. And I'm going to use P Ij to designate the last subscript on my Z partition. And then we have a Zijk is in the interval zijk minus 1 zijk. Okay? Does all that make sense?
Except for some of the subscripts.
Some of the what?
Some of the subscripts.
Well, again, and it's maybe going to be a little clearer if we put stars on the xi's, because I did that last time. Okay? So, what this means is for an xi star, for the xi star in your arbitrary interval here, then all your y's, your y partition is only for the y's that go from here to here, reference to the xi star, right? Okay? Getting a little long in this thing, but I think we'll make it. I hate to split videos. You know, all I have to do to not have to split videos is fill out a little form for YouTube. They call me. There's a robocall that comes within a few seconds. Okay? So I just got to be near a phone. Do I ever think of this when I'm near a phone? I mean, I got a phone in my pocket, but I'll be darned if I'm going to use it. I don't know what the number is. Okay, it's for emergencies. Okay, well, anyhow, I don't live in that thing. Okay, well, yeah, digression, but here we go. So the point is, this video is getting a little long. Actually, yeah, we'll continue. Okay, so again, your typical xi star in your typical interval, ith interval, gives you limits on y. Those limits have to be referenced in terms of I. You'll have a different limit for a different xi, right? So if I is 12, you're going to have 12, 0 through 12, M12. If I is 7,986,486, then you're going to have Y 7,486, 0 through the YIM 748, you know, whatever. Okay? Make sense? Shouldn't have picked so big a number this early in the morning. Okay, you know, working memory starts fading. Okay, anyhow, here we've got now, so we've got an I and a J, just corresponding to kind of what you have here, but now this would be an XI star, Y, J star. So your Z interval, which has to go from here to here, is referenced to the I and the J. Okay? So you got to reference everything to the I and J. And of course this leads to the way you nest your interval. Okay, we're going to stop here.